Hello and welcome to Module 6 of Urban Planning. In this module, we shall be discussing surveying practice and technical drafting. That is the spatial backbone of urban planning. The module content here include overview of land surveying and mapping, how to become a professional surveyor. We will also look at surveyor method, instrument, and field techniques. We'll look at survey draft, that is their type, symbol, and standard. We'll now finally look at the interpretation and application of survey plan before we now draw our conclusion. Let us begin with the introduction, the foundation role. Why surveying and drafting are non-negotiable? Every urban plan begins with the ground truth. Therefore, surveying provides the accurate spatial data on land, boundaries, and features. Technical drafting translates this data into standardized visual language of plans and maps. Together, they form the essential link between planning consent and physical implementation. Urban planners must understand these tools to collaborate effectively, ensure accuracy, and avoid costly errors. Having known that, let us look at land surveying and mapping. That is the science of measuring our world. What is land surveying? Land surveying, by a way of definition, may be defined as the science and act of determining the relative position of a point on the earth's surface to create map and legal description. The purpose of surveying in urban planning include: 1. To establish property boundaries, that is cadastral surveying. 2. To map topography and features, so to determine map topography and their features, which is topographic surveying. Number 3 purpose is to create the control network for all other works, which is control surveying. And finally, to support engineering and construction, which entails engineering surveying. Mapping, on the other hand, may be defined as the graphical representation of this data, now determined by digital tools such as GIS, GNSS, and remote sensing. Let us define the professional surveyor's path. So let's look at the professional surveyor's path. That is the path through which a professional surveyor must undergo, which involves rigorous training for critical roles. So to become a professional surveyor, the following paths are necessary. 1, you must first of all obtain academic foundation. Academic foundation like BSc in surveying, geomatics, or related field is a sine qua non. Number 2, supervised training and internship. It is also require mandatory field work under a licensed surveyor. Number 3 is professional licensing exam. One need to take test technical skills in laws and ethics. So it is another criteria to become a professional surveyor. Number 4 is continuous education, which will help you to stay current with changing technologies. Example, the use of drone, LiDAR, and laws. The key competency for planners to respect include legal acumen. So the professional have to respect the legal acumen by having a deep knowledge of land law and tenure. Another area is technical mastery, which involve having advanced instrument and software. Number 3 is ethical integrity, which involve work must be impartial and accurate as it affects wealth and rights. So a professional surveyor must be ethically in terms of integrity. Let us look at modern survey method and instrument. That is the instrument used in modern surveying. Some of the instruments used in modern surveying ranges from tape to total station to drone. So the traditional to high-tech evolution. Then it was based on the use of chain, tapes, theodolite, and thumping level. So the traditional method involves the use of chain, tape. It was based on analytical, such as theodolite, dumping levels. But now It's now involved in the use of total station, which involve the use of integrated angles and measuring distance, so, such as GNSS, GPS, that is satellite position, 3D laser scanners, and drone for photogrammetries. So the modern trend involves the use of digital technologies like such as GPS in surveying. Now, the common urban survey types include, we have topographic survey, which captures contour, building, trees based on the map for design. Number two types of survey is cadastral stroke boundary survey, which determines legal property lines. We have engineering survey, which involve which is used for construction of road, which set out construction plan on the ground. Then we have control surveyor that establishes citywide precision reference point. So these are some of the typology of surveyor we have. Now let us look at a closer look. That's the key survey instrument. That's the toolbox for precision. Number one is total station. What it does, total station is used to measure angles and distances electronically. The workhouse of modern surveying. So total station is used to measure angle and distance in electronic form. It is the workhouse, the workhorse of modern surveying. Then the urban use, it is used for precise layout for road, building, and infrastructure. Now we have GNSS and GPS receiver. What it does is that it uses satellite signal for precise position, which can be measured in cm level. Then the urban use involve large-scale topographic survey establishing control points. So in urban area, it is used for large-scale photographic survey, which help to establish control point. We have another measuring instrument, which is 3D laser scanner, that the leader. What it does is that it creates a dense, that is point on cloud of millions of measurements for a 3D model. The urban use include, it helps in the documentation of complex existing structure as built survey. Then the last one is the survey drone, UAV. What it does is that it captures aerial images for photogrammetry and mapping. The urban use include rapid mapping of large or inaccessible sites, as well as monitoring progress. So let us look at the picture above shows some of the surveying instruments, which includes the drone, the 3D, as well as other surveying instruments as shown on the screen. Now let us look at the technical drafting. That's the visual language of surveying. So the technical drafting is the visual language that is turning data into understandable plans. What are survey drafts? A survey draft is a standardized technical drawing that presents survey data in form of map, plans, and diagrams. Why standard matters is because, one, it ensures universal understanding across the profession, like planners, engineers, and lawyers. So it ensures universal understanding. So standard is very much important. Two, it guarantees legal validity for plans used in permits and deed. So it guarantees validity. Standard also helps to maintain consistency and clarity. The key output, that is the draft types, include, we have cadastral plan, which shows property boundaries for legal purposes. We have topographic stroke contour plan, which shows elevation and physical features for design. We have site and layout plan that shows detailed proposal for a specific plot. Then lastly, we have land information plan, LIP, which composite map with boundaries, features, and zoning. Having known that, let us look at the grammar of drafting, including their symbol, their symbols and standard. How to read a plan. That is standardized symbol, the visual alphabet. How to read a plan include point the symbol, such as benchmark BM and manhole. So you now point the symbol. Some of the symbol include benchmark and manhole. Now, line symbol includes solid, which is certain boundaries, dashes, which is on certain fence. So, a symbol include line, which could be solid line that satisfies certain boundaries. It could be the use of dash, which is uncertain or fence. We have area symbol, which involves shading and hitching for land use. Example is green for park. So we use area symbol. Maybe we use green color to showcase maybe a park. We have an annotation, which is text for dimension, level, and node. So we can use annotation in form of text to read a map. Then the critical drafting standard includes scale, which must be clearly stated. Example, 1 is to ratio 500, which define the level of the level of the details. We have title block that contains the project name, survey, date, client, and the scale. So these are some of the content of the plan that must be read. Then we have north arrow and coordinate system, which is essential for orientation. Then we also have accuracy statement such as plus or minus 0.5 meter for horizontal accuracy. Now the digital format includes DWG for card, SHP for geography information system, which is used for interoperabilities. So this is how to read a survey plan. Now let us look at interpreting a survey plan, the practical guide. What do you look for? The step-by-step interpretation includes, first of all, check the title box. Who, what, where, and when, and the scale. So the title, they check the title block that tells you who owns the plan, what, where is it located, when is it measured, and the scale of the survey plan. Number two, identify the boundary. Look for the closure polygon with dimension and bearing in order to identify the boundary. Number three, look for markers. So using symbol for survey pen, the beacon that exists on the ground. So you check your beacon that exists on the ground, symbol for survey pin. Then number four, note the features such as building, road, trees, utilities within the boundary. Then number five, find the restriction, that is easement, utility right of way, and setback, that is no build zone. Then number six, the last, verify the area, that is the calculated size of the parcel. Then the common pitfall for planners is misinterpreting and approximate boundaries from real estate sketch as legally precise survey boundaries. So the pitfall is misinterpreting an appropriate boundary for a real estate sketch as legally precise survey boundaries. So this must be avoided. Then let us look at application in urban planning and management. That is from paper to practice. How planners use survey plans. So survey plan may be used in land use and zoning, which is used to verify parcel size and shape for zoning compliance. It may also be used in infrastructural design, which is involved. It is used to it helps use to topographic data to design road, drainage, and utilities. Survey plan may also be used in development control, which helps to check proposed building location against setback and easement. Then in conflict resolution, it also helps to provide objective evidence in boundary or encroachment dispute. It may also be used in geography information system database creation, which helps to, that is survey plan feed the authoritative spatial data layer for city-wide geography information system. Now let us look at real world example. A planner uses a topographic survey to design a park, ensuring path follows the natural contour, that is the gradient, and drainage is managed effectively. So this is real world example. In conclusion, the indispensable partnership, that is surveyor and planners and surveyor better together. Surveying provides the factual spatial foundation, while planning provides the vision and policy framework. Technical drafting is the common language that allows this collaboration. Ignoring precise survey data leads to plans that are beautiful on paper but unworkable on the ground. Embracing this partnership leads to legally sound, implementable, and sustainable urban development. Thank you, and God bless you.